Hello everyone, my name is Yogendra Kumar. I am a DevOps consultant based in Delhi, India, and welcome to this session. Here I am going to talk about what is Docker containers. Before the Docker containers, what are the containers? So, if I talk about the simple definition of the containers, containers are a solution to the problem of how to get software to run reliably when moved from a one computing environment to the another. So this could be from a developer's laptop to a test environment, or from a staging environment into a production in any type of infrastructure like a private cloud or a public cloud. So problem arise when supporting environments is not identical, where we are going to deploy our applications. So suppose you are going to test your application using Python 2.7, and then it's going to run on a Python 3 in a production. Then something weird will happen with your application. Or say you will run your test on the Devin, and in a production you are going to deploy your application on Ubuntu. So all sorts of weird things will happen with your application. So how do containers solve this problem? So put simply, a container consists of an environment runtime and an application plus all its dependencies, libraries and other binaries and configuration file needed to run it, bundled into one package. So by containerizing the application, platforms and its dependencies, differences in OS distributions and underlying infrastructure are abstracted away. So there are many containers formats available. So Docker is one of the popular open source container format amongst them. So what is Docker? So Docker is a popular runtime environment used to create and build software inside containers. And it uses Docker image to deploy containerized application or software in a multiple environments from development to test and production. So a Docker image includes the element needed to run a application as a container, such as a code, config files, environment variables, libraries, and the runtime. If image is deployed to a Docker environment, it can be executed as a container. So when we provide the runtime to the Docker image, it hosts the container, and inside the container you will host your application. So now let's try to understand the problem and the solution Docker has got to offer the problem. Let's say you have a three different Python based application that you plan to host on one single server, which could be either a physical machine or could be a virtual machine. And each of these application makes use of a different version of a Python, as well as the associated library and the dependency differ from one application to the another. Since we cannot have a different version of Python installed on the same machine, this is not a best practice too we can have, but it will create a conflict between them. So this prevent us from hosting all three applications on the same computer. Let's look at how we could solve this problem without making use of a Docker. In such scenario, we could solve this problem either by having a three physical machine or a single physical machine which is powerful enough to host and run three virtual machine on it. So both the option would allow us to install different version of a Python on each of these machines along with their associated dependency. So in respective of which solution we choose, the cost associated with the procuring and maintaining the hardware are quite expensive. So Docker provides the ability to package and run an application in a loosely isolated environment called a container. So the isolated and security allow you to run many containers simultaneously on a single host. So you don't need three physical machine or three virtual machines. We can solve this problem with the help of the container. So in this image, you can say right side on a one host, we can have a multiple container of different applications. So it will isolate the runtime environment for each application, and which will not create any conflict amongst them. So why containers? So when we discuss about the containers, then most of the people get confused amongst virtualization and the containers. So think of a container as another form of a virtualization, as VM also just one form of a virtualization. and that divide the hardware in a different host machines, and can be shared among a different users and appears as a separate server or a machine. But the container virtualize the OS, not splitting the hardware. It's splitting the virtualized components to run container application. So Docker containers are very lightweight and alternative to the virtual machine, and unlike this VMs. And containers are not only faster and easier to use than a VMs, they also make for a more efficient use of a computing hardware. And there are a lot of benefits of a container, Docker container. So we have like the most important benefit is the less overhead. When we use container, require less system resources than a traditional or hardware virtualization machine environment, and increase the portability. So application running in one container can be deployed easily to multiple different operating system and hardware platform, and it's a more consistent operation. So DevOps team knows application in container will run the same regardless of where they are deployed, and great efficiency. So container allow application to be more rapidly deploy, patched or scaled. So it will help to both developers and the operation teams. And nowadays the common ways organization use containers for lift and shift. So existing application into a modern cloud architecture. So it help us to for moving our application into a modern cloud architecture if we are running our application inside the container. So this is what about we should know about the container. So now in this session I'm going to show you a live demo of a application where I will containerize a Flask Python application.
So this is the high level architecture of how to dockerize a Python Flask application. So here I have developed the Python code. So that is the Flask app and hosting a API. Then I developed one Docker file. So in the Docker file I have mentioned all the instruction to build a Docker image. So when I build it, so it will package all the required dependency and all the libraries for that Flask app, and it will package as a Docker image. And I will push that Docker image to the Docker registry if I want to distribute the same image on a different environment. So I can keep that image into the Docker registry, and then I will provide a runtime to that Docker image, and which will host the Docker container, the Flask app container, and then I can access that app to perform the operation over that application to make the get and post code. So prerequisite for this demo is the Docker engine should be installed on your machine. So I have developed one shell script to install the Docker and Docker engine and all the required libraries. So you can use it, and when you will run it, first it will check if the Docker is already exist or not. If Docker already exists, then it will not install the Docker, but if it doesn't exist, then it will install the Docker over that machine. So then I will show you here the Docker file, which will help us to build a Docker image, and then we will provide the runtime to that Docker image. Then it will host a Docker container. So here you can see here that we are starting from the Linux as a base image. So as it is more clear in which Python version is being installed, so we can use the apt or apt-get install to install all the required libraries for this application on the Ubuntu or any other operating system like Debian. And yum, with the help of the yum installer, we can install these dependency on the Red Hat and the CentOS operating system if you are using the base for the Red Hat or other operating system. So let's go over some of these Docker instructions. So here you can see that these and operator is not a Docker specific, but tell us Linux to run the next command as a part of existing line. And instead of using the multiple run directories, you can use just one. And then there is like you are defining the work directory for your Flask application, that is the Flask app, and you are copying the all the content from this directory, which I developed the Python application, the Python Flask API, which having the get and post call to to perform the operation with the DB. Then in the last here you can see I'm just I'm making a symbolic link of a Python 3.6 so that I can access this Python globally on my this base system, the Ubuntu 16.04, and then I'm installing the pip installer to install all the required packages for my application for this Flask app. So I have mentioned all the required libraries, those will require for this application runtime. So then here I'm just installing for installing those library, I'm installing this pip installer, and then I'm running it and install -r. It will install all the required library on this base. And in the last there is an entry point, configure the container to run as an executable, and only the last entry point instructions executes. So it will run the Python Flask app, and it will host the API. So this is my API folder. So then I will show you how to build a Docker image. You have to install the Docker on that machine. So I have developed this script to install the Docker engine. So here you can see that it's giving the Docker version, because on my machine I have already installed that, and it will print the message like this: Docker is already installed and with the current version. So it will show the version as well. If Docker is not available on your machine, so it will check the condition. If it's not available in the machine, it will install this Docker. And I have this function in the shell script. It will install all the required packages and the libraries for this Docker runtime engine. This Docker build command should be run from the root user. So now I will write a command. So the command is docker build, and you can give the tag value. So for tagging the image, you can use the -t options. So I will give the tag value is a Flask app new, and the version I will give 1.0. And because the Docker file is in my current directory, so I will use a dot. So it will pick the current Docker file from the current directory. And now it will take some time to install all the required packages on the base Ubuntu base, which I am using in my Docker file, and then it will install all the required packages from the requirement.txt file, and then it will build an image and will give you the tag name for that image after building it successfully. Okay, so now you can see that my image has been built, and it has been tagged with the name which I have passed with the build command. And now I can use and I can provide the runtime environment to this tag, this image, the Docker image, and it will host a Docker container, in which Docker container it will host the API, the Flask API. So now I'm going to provide the runtime to Docker image. This is the command which will provide the runtime to the Docker image, which we build with the help of the docker build command. So this was the tag name which we provided at the time of building the image. Now we will provide the runtime to this, and it will host the Docker container. So I will hit this command, and then you will see that Docker container has been hosted, and in that there is a Flask app has been hosted. So we can check that if Docker container has been hosted or not. So we can use the command is docker container, and then you can list down all the container, and from that I will grab this particular container. So you can see here that that's with the same configuration. So in the environment file which I am passing over here, I am having the db string value, which will use as an environment variable inside the container. So the app has been started, and this is the status of this container is up. Now I will access this API. So I've already provided the runtime to that Docker image, and which is hosting this API. So this is my API. Here I am having 3 calls. One is the get call and 2 post calls. So in the post call I'm uploading the payload like this. So this will require the email address and the username. Then it will store into the DB, and same kind of a step I can upload the bulk upload with the help of this CSV, and I can have this 2 columns in the CSV, one for the mail ID and one for the username. Then the bulk upload I can upload from this Swagger API from here. And the first function is the get. So when I will hit this get call, it will give me all the details about the current data in the DB. And here you can see that it's executing, because I have a lot of data in the DB table, so it will take couple of minutes to get the data from the DB, and then you will be able to see the results over here. And this application is hosting over the container, the Docker container, inside the Docker container. And so like this, I've already built the image, the Flask app image, so I can distribute the same image on a different environment in respect of any prerequisite. So everything, all the required library and all the required setting is enabled already in that image. So I can use the same Docker image to run this app on the different environment without any prerequisite changes or steps. Thanks for watching this video. Have a nice day.